work. If you go to this website, you will see the structure of the JK flip-flop. What is JK flip-flop? The JK flip-flop is the, like when both inputs are 0, the output will not change. When both are 1, it changes, and also when it's different, the output will be J. So we want to use this feature for counting up and down, but for we want to set the JK flip-flop at the location that both inputs connect together, and the output will sometimes change or not change. And use this structure for our counter and for 4-bit counter. So use this feature, and then we can design a JK flip-flop. First, there are 2 structures for JK flip-flop. As you will see, there is a simple structure and also master-slave structure. You can design both, but as you see here, for the JK single structure of JK flip-flop, you have toggling problems. When the clock changes, you have some time to you have a single time that the output will be set to one number. So if you design that circuit, you will lose some points because of these parts. So it's better to use a JK flip-flop with a master-slave structure. That by designing this one, you will not face this problem, and you can get a full mark. So first, you need to design this JK flip-flop. As you will see, the JK flip-flop considered as a NAND gate and NOT gate. So, as you know, for the project 3, you design the NAND gate. So go to project 3 files. So you have the NAND gate. So design the schematic. You have the schematic, and also you have the layout. You don't need to change anything. The only difference is that here you have also some NAND gates with 3 inputs, as you see. In the inputs, you have the JK flip-flop with 3 inputs. So based on this NAND that you design the NAND gate with 3 inputs, and then design the schematic and layout. So what's the difference between the NAND with 3 inputs and the NAND with 2 inputs is same. Like if you have this design that has a NAND with 2 inputs, for example, this is the NAND with 2 inputs. This is the output. So you want to make it as a 3 inputs. The only difference is that you add 1 NPN here, and go to C, for example, this is B, this is A. And 1 PNP here parallel to the circuits. So the only difference is that you will add 1 transistors on the PNP, 1 transistors on the NPN. And you have a NAND gate with 3 inputs. So that's it, it's very easy. So from now, you don't need to design a circuit like NAND. You have that for NAND for 3 inputs, add 2 transistors, 1 PNP, 1 NPN. And then after you design that, you have also inverter here. Again, you have the inverter for project 1. So go to the file of your project 1 and use the inverter. The schematic layout. And then after you find these files from your library, then you need to design this JK flip-flop. So go there and design the JK flip-flop. So based on these 3 circuits that you have, design the schematic, design the layout. And then for these, after you design the JK flip-flop, go to the project, you will see we need a schematic. So first you design a schematic. Then a schematic output waveforms. What the meaning of this one? You need to put the JK flip-flop test bench. So after you design the JK flip-flop, put the JK flip-flop TV. And then on this one, you need to test the circuit. What's the inputs? You have the J, you have the K, and you have VDD and GND based on the design of the JK flip-flop. So you have this circuit. You have J, K clock. Also clock. So for the J, put the V pulse. For the K, also put the V pulse, and clock also V pulse. But the J and K, it's better to have different pulse, like different period, or put a delay for K. Because I wanna see all the conditions for the JK flip-flop, the table that I showed you. I wanna see that when the J and K is 0 and then clock also change, the Q doesn't change. All these 4 conditions. And also, the output change only when the clock also change. So make a condition that you will see all the conditions. Like one of the way is to put a J and then have a K with like a bigger pulse speed, and then a clock with a smaller pulse speed compared to the 2 circuits, something like this. Or you can put a K same as the J with a delay line, with a delay. When you want to put a V pulse, it asks you a delay time. So you can also put something like this. So these are the way that you can put the V pulse. So put some numbers on the pulse width and periods, and then check the conditions. Okay, after you output waveform, design the layout. So I showed you design the layout of this JK flip-flop based on the 3 circuit that you had, DRC, LVS, and parasitic simulation. So after that, you need to design you pass the DRC of this layout, DRC, LVS, and take a screenshot of these 2. And then you need to also run again parasitic simulation post layout. So do the post layout of this one, and then again on this test bench, see the results, see the waveforms. So you need to show me the results of the first layout and also the layout, 2 outputs. Okay, after you design the JK flip-flop, the next part is to design the up and down counter by using this cascade JK flip-flops. With cascade JK flip-flops, you can design the up and down counter. So up and down counter, again, you can see on the internet if you go and search. Look, I mentioned JK flip-flop with reset, but it's not mandatory. You can design this circuit, it works also. But if you wanna, like I mentioned, the JK flip-flop with reset, you can also put the JK flip-flop with reset. If you go and search JK flip-flop with reset, look, this is for example circuit with reset. The reset, the only difference is that the reset part has more input on one of the NAND outputs, and it's not like mandatory. You can design the simple structure or with this reset. And then after you design that, search 4-bit counter, 4-bit. This is a 3-bit counter. Okay, the only difference on your design is to this T flip-flop. The same, but yeah, this one is good. This is the 4-bit counter. This formula is right, yeah. This circuit, look. This is a 4-bit counter. How it works, look, the JK flip-flop on this circuit, the input connected to the VDD. So, when the input connected to VDD, it means that the JK flip-flop has only 2 conditions. J and K. Sometimes both are 0, sometimes both are 1. If both are 0, the output will not change. And if the both input, the output will change, invert the inputs. So on this circuit, the J and K always connected to VDD. So it means you only use this condition of the JK flip-flop. And the output always change when the clock comes to the circuit. So every time that the clock goes to the circuit, look, this is the clock. that has a V pulse. V pulse goes to the clock, of the JK flip-flop, and every time that the clock comes, the output will change. So if you see the output of the first JK flip-flop, Q0, first JK flip-flop. Every time that the clock comes, the output will change. So for example, if it's 0, then the next clock will be 1, next clock will be 0, because it changes every time. 1, 0, 1. The second JK flip-flop. The second JK flip-flop is changed. Look, the input of the second JK flip-flop comes from the output of the first JK flip-flop and with up and down control signal. So for example, if you want to do the up counting, so the up and down will be 1 volt. 1 means 2.5 volt. And then the end of this one, and when the JK flip-flop output also when the output will be 1, the end will be 1 also. So the 1 goes to this OR, and the OR always will be 1, and then this JK flip-flop also change the inputs because both inputs are 1. So the second JK flip-flop only change when the up and down is 1, and also the first JK flip-flop output is 1. So look, for example, if the first output JK flip-flop is 0, so the second one will be 0 also. When it's 1, the output must be changed. But there is one delay between these two because there is one step after the first JK flip-flop. So it will be changed on the next clock. So it means that when it's 1, the output will be changed. So here also will be 0, and then at this location will be changed to 1. Again, it's 0, so it doesn't change, so it will be 1. Then it's 1, so at this next step it will be changed to 0. And then it's 0, so it will be 0 again. Okay, this is the structure of second stage. What about the third stage? The third stage will change. The third stage, as you see on the structure, the third stage will change this NAND. When the second output is 1, one of them comes from the second, this one, and the other one goes from the output of the first one. So it changes only the first one is 1, and the second one also is 1. So for the third one, it changes only both of them are 1. So for example, the first one will be 0, 1, 0, so the output will be 0, 0, 1, 0, 1, 1. At this location, the output of the third one with the 1 delay will be 1. So with 1 delay, it will be changed to 1. So this one also will be 0. Then 0, 0 doesn't change, 1, 0 doesn't change. So as you see, it's like a counter. 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. And like a counter, you have a circuit that counting up and down. So you design the counting circuit. This is the like 1 bit. This is the second bit. This is the first. And you will see it's like a counting circuit, up counting circuit. So you need to design this circuit. After you design the JK flip-flop, you have the inverter again. You have the NAND and OR gate. So as I think you design the NAND gate, so the only difference is that you put this NAND gate with one inverter at the end of that, and then design your AND gate. So for the AND gate, put this NAND gate from project 3 and put the inverter after that, and then design the schematic and layout. The other circuit will be OR. I think you didn't design the OR, so you need to design the OR for the first time. So design the OR gate and then a schematic layout. For the OR gate also it's like similar. You can check on internet. So search OR gate CMOS. This is the OR gate. So the OR gate also will be this one. Put this circuit on the schematic, design the layout, and also design the schematic. So this will be the OR gate. And after you design the OR gate, you need to go and design this 4-bit counter. So put the OR everything JK flip-flop and design one thing, that one more cell view that the name will be 4-bit counter. For this circuit, design the schematic, design the layout, and then you need to put the 4-bit, and on the layout has DRC, LVS, take a screenshot of these two, and then 4-bit counter test bench, run the circuit and show the waveforms, and then do the post layout again for this circuit, post layout, and show the output of the parasitic circuits. So how you can test this circuit? Look, you have the clock will be V-pulse. So you have V-pulse again, same as the JK flip-flop. You have one VDD that's connected to the J and K, so that will be 1 volt, 2.5 volt. You have up and down. For the up and down, use the VDC. If you want to do the up counting, put a 2.5 volt. If you want to do the down counting, put 0 volt. And then you have 4 outputs, Q0 to Q3, and show these outputs. That's it. So based on this design, and then on the output, like see the Q0 to Q4, and one time do the up counting and show me the result of the up counting, and the next time show the down counting. So 2 outputs for the schematic, two times you need to run the schematic, and 2 times you need to run the post layout. 4 outputs you need to show me on the 4-bit counter. So based on this design, the NAND gate, you have it right now. The NAND with 3 inputs, a little bit difference. Add one transistor to this one, it's easy. Inverter, you have it. JK flip-flop, you need to design. JK flip-flop test and design. And you have the NAND plus inverter, so it's easy. Again, you need to only put one inverter after the NAND. OR gate, you need to design, and also 4-bit counter and 4-bit counter test bench. So 3 design you need: JK flip-flop, OR, and 4-bit counter. 3 circuits. Again, the process, like the demonstration will be same as the project 3. You will come to my office on the last week and last week of the quarter, and then I will ask some questions again. Run the post layout, run the layout. It's better also to try to do some part of the post layout if you couldn't get the results, because if you do some portion of that, you will get also points of some part of that instead of getting 0 if you don't show me any result on the post layout. So try to get any outputs from your design instead of telling me that you have not do that. Okay, if you have any questions, you can ask.
For the V-pulse we use, so is it the same value we using like the project 1?
V-pulse?
Yeah.
Project 1 was the inverter, but if you asking about the project 3 that uses V-pulse, yeah, same as the V-pulse will be same as the project 3. Yeah. Same pulse with same periods. But as I mentioned, the clock period must be lower than the J and K inputs also. Do you have another question?
Yeah, how would you like so?
So now no one has a question. The class is over. I will help you regarding your problems on your design, and then I will see you. We have